All right, so let's look at a box plot, which is a graph that gives us a visualization of the spread using the five-number summary. So it's a visualization of the five-number summary. To create a box plot, we're going to do three things. We're going to create an axis or a number line that spans the range of the data we want to represent in our set. We're also going to then do a rectangle above that axis that represents the middle 50% of the data. So that would be what would be from Q1 to Q3 with a vertical line drawn at the location of the median. And then we're going to have whiskers or horizontal lines that come off each side of the rectangle going out to the maxes and min values. What this does is it gives us a really simple way of being able to visualize really how spread out by comparing it with a number line. And number lines are going to be consistently spaced. So then you get a sense of, is the middle 50% of the data really close together and then you only have lots of spread on the edges, or do you have more spread on one half of the data compared to the other by looking at how everything relates in the number line. Another good thing about box plots is that you can take similar data sets and by graphing box plots next to each other using the same axis, you can very easily compare the spread of those two data sets. And since we had two data sets on the last example, we had phone company A and phone company B. Phone company A had a five-number summary that was 24, 25, 27, 28.5, and 30. Phone company B had a five-number summary that was 10, 26, 27, 27.5, and 28. So let's take a look at these two data sets together. We have to start by looking at our creating our axis because we need something to graph the data against. So we need to start with our axis. To do that, let's look at the lowest value for both of these sets, and that would be 10. So we'd want to start our axis at 10 on the left, and then we know we need to go as high as 30, which is the highest value. So we want to make sure we have plenty of room to get up to 30. Well, we can spread out here, but we probably don't want to go by 1, 2, 3, 4, 5. That would take us a while to get to 30. So why don't we go by twos? So I might have 12 here. Now when I go to 14, I want to make sure I have spacing that's about the same. So 14, spacing the same. I would have 16. You can use a ruler to space this the same. 18, 20, and we keep up that spacing. 22, 24, 26, 28, and I kind of barely get up to 30 right here. I kind of sneak my 30 in there and extend my line here. So 20, whoops, that's 22, 24, 26, 28. All right, so you want to make sure you have a consistent spacing. You don't want to have spacing between 20 and 22 be smaller than the spacing between 22 and 24, because then you would be representing the widths differently for the same unit space. So we want to make sure we take some time to put our axes together so we can see how space works appropriately. All right, now let's create the box plots on above the axis, and you're always going to put the box plots above the axis, not on top of the axis. Let's start with phone company A. We're going to start with a rectangle that includes the middle 50% of the data. So the middle 50% of the data goes from 25 to 28.5. So it's right at the top here. So 25 is halfway between 24 and 26, and then 8.5 would be halfway between 28 and 29. So I have a little tick here where 29 would be. Halfway between 28 and 29 would be about here. So I put the box together, just a nice little rectangle. This is the box of a box plot. And then we will put a vertical line at the median. So the median was at 27, so I'll put a little vertical line here. And right away, one of the things you can see when I make that vertical line is that the region that would be the 25% of the data that is in the middle but but not the lowest 25% of the data, kind of the second 25% of the data, is wider than the third 25% of the data. So you have more spread right here in this region than you have in this region, the second region here. So it shows you just visually because you're comparing it to a number line. Now, the spread isn't much. When we look at the number line, we're talking about the difference between 25 and 27, which is 2 units, and 27 and 28.5, which is 1.5. So there's not a whole lot of difference, but there you can visually see that there is some difference there. Now we'll do the whiskers. The whiskers go to the minimum and the maximum. And whiskers are just going to be horizontal lines that come out from the middle of the rectangle out to where the minimum is, and then out to where the maximum is. I made that a little too far. So out to 24 for the minimum, and then up to 30 for the maximum. So there's our graph. And I put a little stopper, you might say, right at the edge. That's often common to do with a box plot. You don't have to do that, but it's a nice way to kind of visualize that we're stopping there. So there's my box plot for phone company A. Now to compare that with phone company B, I'm going to just draw phone company B's box plot kind of right above there, and we'll be able to compare. So phone company B has a middle 50% that goes from 26 to 27.5. So 26 is right about here to 27.5. Now 27.5, 27 is here, so 27.5 would be about here, halfway between 27 and 28. So my box for the middle 50% of the data is much smaller. It is much thinner than in the box for the phone company A. And then I put the median in at 27. So the median is exactly the same on both of these, and you can see they line up. But the box is much narrower for phone company B. That means that data for the middle 50% is much narrower. It's much less spread out. So this is a much more packed data set in the middle 50%. Now we'll go out to the minimum and the maximum. The maximum just goes up to 28, so doesn't go out very high. So we still have a very tightly packed data set. But here's where we get the interesting thing with the minimum. That minimum is 10, so we have a whisker that goes all the way out to 10. So what we see with the whisker here is that what's happening is we have a lot of spread because we have such a low minimum. But most of the data is very tightly packed. That middle 50%, in fact, the upper 75% of the data, all of this is very tightly packed. So you can very quickly see that the data for phone company B is more consistent. It's less spread out, even though none of this data is very spread out, but that group, that 75% of phone company B's is very tightly packed. It's very consistent. And you have a kind of an outlier there of 10, which creates spread in terms of the number line or the box plot.